Today we're looking at the Cartesian plane. The Cartesian plane is named after its inventor, René Descartes. It consists of two axes. So you've got your x-axis and your y-axis. At the center point here, that's called the origin. So your origin is 0, 0, and we write that as the origin 0, 0. Okay, so first term is our origin in the middle. Then we have our x-axis, which goes in both a positive and a negative direction. So on the right here is our positive direction for our x values, and on the left is the negative values for our x-axis. Similarly with the y-axis, positive values going upwards and negative values going downwards. When we're using a Cartesian plane, we often plot coordinates. So plot means basically draw coordinates. And what coordinates are, you should have seen these before, are in brackets. They're always in brackets, so it's easy to tell that they are coordinates. You have your x value and your y value. Okay, so these Cartesian coordinates here in brackets are made up of an x value and a y value. So for instance, just a simple one, 1, 1. Okay, so the x value is 1 and the y value is 1. So we can plot that right there. We can also plot negative values, -3 and -2. So we go to our x-axis, -3 is there, and then we go down 2. So that's where our -3 and -2 would be on our Cartesian plane. With your Cartesian plane, you often use it to plot certain points using an equation. So given a set of coordinates, such as the ones we have here, we can just draw these or plot these on our Cartesian plane. But rather than being given just a long list of coordinates and then plotting them on the graph, we can use what they call a linear equation. Linear equation. Now, when you look at the name of this, it gives away what it does. So linear has got line in it, okay? So linear equations are all about drawing straight lines on our Cartesian plane. So let's just have a look at some examples of those. Just erase these. Okay, and a linear equation. Now linear equations generally take the form of y equals, say, 2x plus 1. Okay, let's have a better look at this. So linear equation, you plot the y values here, our y values. We plot our y values based on the value of our x values when they're plugged into our equation. So say we were given an x value of just simply 1. So we can plug this x value of 1 into our equation. So it would be y equals 2 times 1 plus 1 equals 3. Okay, so this is a linear equation because there's a relationship between the x values and the y values, and that relationship is given by the linear equation. Now let's just work out a few more x values, and then we're going to draw our line, and it will be a straight line because we're using this linear equation. So let's just put in a few more values. We've got x, we've done it for x, let's do it for -1. So x equal to -1. We'll plug that into our equation as well. So 2 times -1 plus 1, which is, so 2 times -1 is -2, plus 1, so it would be -1. Okay, now given two coordinates, we can draw a line now on our Cartesian plane. We can work out more values though if we wanted to, and quite often I work out what the value of y is when x is 0. I find that very handy, so I'll just do that as well. So y, now we're plugging in x is equal to 0, so it would be 2 times 0, which is 0 of course, plus 1. Okay, so y is going to be 1. Okay, now we have 3 values. Now, generally we put these values into a table. So rather than just having them all along the page spread out, we would put those into a table. So I'll put a table on the left here. And that table is just going to contain some x values and some y values. Use a ruler when you're drawing your table, just to make it a bit neater. So you have your x over here and your y down the bottom. Okay, so our x values, the smallest one we had was -1, and we've also done 0 and we've done 1. Now you can work out more x values if you want to, but given just 2, you should be able to draw a straight line. But I like to always work out at least 3, sometimes 5. Okay, so we've got -1. So over here, we worked out that when x is -1, then y is equal to 1, -1. Okay, and 0, so we worked out down the bottom here was 1. And when it's 1, it's 3. Okay, so we can plot these now on our Cartesian plane. So -1. Okay, so when x isn't equal to -1, here, x isn't equal to -1, y is equal to -1. When x is 0, y is 1. Okay? And when x is 1, y is equal to 3. Okay? So given those 3 points, we can, or coordinates, we can plot our line now. And you would only need 2, but sometimes it's good to work out 3 to 5. I'm just going to draw it, because I don't have a book, I'm just going to draw it freehand. It's not going to look straight, but you should definitely use a ruler. Okay, so that's supposed to be a straight line there. Okay, so we can connect our dots up and draw a straight line. And often we write the equation that we're using, our linear equation, right next to the line. So y equals 2x plus 1. Okay, so that's why we call them linear equations, because when you plug in x values, you get a y value, and from those coordinates, you can then draw a straight line. Now, in your book, you'll also see, rather than just y equals 2x plus 1, you'll also see this, f(x) equals 2x plus 1. Now, just for the sake of what we're doing now, these are equivalent. So where you see fx, it's basically meaning we're working out what our y values are. But this fx, that's what they call function notation. So it's saying the function of x is equal to 2x plus 1. So when you input a value of x, fx is going to be the result. So which in our case will be our y values. So fx and y are equivalent. So don't get confused by that. Just for what we're doing now, fx equals 2x plus 1 is the same as y equals 2x plus 1. It's just a different notation for us.